What if the most powerful thing you could do for your health was simply to stop eating for a few hours? Sounds strange, right? But to understand this, we first need to see what normally happens when we eat. Now, what happens when we eat? When we eat, food is digested in the gastrointestinal tract into smaller molecules such as glucose, amino acids, and fatty acids. These nutrients are absorbed into the bloodstream and transported to cells throughout the body. In response, the pancreas releases the hormone insulin. Insulin helps cells take up these nutrients, use them for energy, and store excess energy, mainly as glycogen in the liver and muscles and as fat in the adipose tissues. Most of us eat every 2 to 3 hours. Breakfast, snacks, coffee breaks, and dinner. Each time we eat, insulin levels rise to help manage and store incoming nutrients. When insulin remains elevated throughout the day, the body primarily uses nutrients for energy and storage. And the switch to using stored fat as fuel becomes limited. This means our metabolism rarely gets a break. This is where intermittent fasting comes in. Intermittent fasting is not a diet. It is an eating pattern based on time. The most common version is the 16:8 method, where you fast for 16 hours and eat within an 8-hour window. Other forms also exist, such as 14:10 method, alternate day fasting, and the 5:2 approach, where calorie intake is reduced on 2 days per week. Importantly, intermittent fasting is different from starvation or prolonged fasting. It involves controlled fasting periods that allow metabolic adaptations while still providing the body with adequate nutrition. Here's what scientific research shows. A meta-analysis found that intermittent fasting reduces body mass index by approximately 0.75 kg per square meter. Fasting glucose levels decrease by around 4.16 milligrams per deciliter. People with metabolic syndrome lost around 2.48 kilograms on average, and body fat decreased by approximately 1.67%. These measurable changes shows that intermittent fasting can influence important metabolic health markers. But what actually happens inside the body during fasting? As fasting continues, insulin levels decrease. This signals fat cells to break down stored triglycerides and release fatty acids into the bloodstream. These fatty acids are then used by tissues such as muscles and liver as an alternative energy source. The liver also produces ketones, which serve as an efficient fuel for the brain. At the cellular level, fasting may activate processes involved in the cellular maintenance and repair, including autophagy, a process where damaged cellular components are broken down and recycled. This helps explain how fasting affects metabolism at multiple levels. Intermittent fasting is not a magic, and it is not suitable for everyone, but for many healthy adults, it can be a simple and structured way to support metabolic health without necessarily changing what you eat, but changing when you eat. However, people with medical conditions, pregnant women, or those on medication should consult a healthcare professional before trying it. If someone wants to try intermittent fasting, starting gradually is important. For example, beginning with a 14-hour fasting and 10-hour eating window can help the body adjust. Staying hydrated is essential. Avoid overeating during the eating window. Focus on balanced whole foods, and most importantly, consistency matters more than perfection. So what happens when you stop eating for a few hours? Your body shifts its energy source. Stored nutrients become available, and important metabolic processes supporting cellular maintenance are activated. Intermittent fasting is not about restriction. It is about understanding how our metabolism works. And that is the science behind intermittent fasting.